Welcome to this webinar on early warning solutions for gas leak detection. My name is René Braun, CEO of Grandperspective. I will show you today a case study on a gas leak in an ammonia plant that resulted in a very dangerous situation due to an undetected gas leak. And I will present a new early warning solution that covers both the hazard prevention and rapid incident mitigation. One of the major risks in ammonia plants is the risk of fire caused by gas leaks. In some cases, explosions occur, and from those cases, the hydrogen-rich gases, mainly synthesis gas, are the main reason. The most common fires in ammonia plants are either from flange leaks, where hydrogen-rich gas catches fire, or from oil leaks associated with compressor and loop oil pump and seal oil systems. At present moment, a significant number of plant operators need to decide based on the sparse information coming from gas sensors, which do not always reflect the reality in the field. An analysis of the offshore hydrocarbons release database by the Health and Safety Executive reveals that approximately 36% of major gas leaks and 69% of significant gas releases were undetected by gas detectors. The decision process for or against an expensive intervention in an uncertain risk situation involves the danger to act with too little, too late. Statistics say the accuracy of detection systems is not always reliable, and so many leaks go undetected. Why? Well, a gas sensor only picks up the gas when it is slap bang in the plume. Once it is off the center of the plume by just a few meters, the concentration measurement gives you an entirely wrong picture of the situation at hand. Imagine this. During a normal routine shift, the leak detection system triggers an alarm in the DCS. What is the next set of maneuvers? Most probably, the DCS operators send the field operator or firefighter with a portable sensor to check for the leak. First question that goes to his mind is this leak real or just another false alarm? Then, if the leak is real, how big is the leak? Does my interpretation of the situation result in a shutdown of the plant right now? Or if the leak is small, can we still run the plant to meet the production target? Or at least until those spare parts will arrive, so we can fix more problems at once if we stop the plant? Now let's suppose the gas leak is real. The leak detection system picks it up correctly and indicates a problem. A gas cloud is dispersed through the plant, influenced by the leak location, the hole size and orientation, pressure, piping congestion, and, of course, the wind direction. Once the field operator is going to check for the leak, another question will arise. Where exactly is the leak? How big is the flammable volume of the gas cloud? How can we prevent that the operator will not enter the gas cloud entirely during his checks? Will the windsock check be enough to assume that the approach is correct? And the operator will not enter the gas cloud that will engulf him in a ball of fire in case of ignition? Now let's have a look at a study of a real case that happened in an ammonia plant in Europe. In December 2006, during normal operation of the ammonia plant at a production rate of 100%, the DCS operator received an activation of the low temperature alarm on the outlet of 103C heat exchanger. In normal operation, this temperature remains around 335 degrees Celsius, or roughly 600 degrees Fahrenheit. The recorded temperature value at this time was 147 degrees Celsius, or just below 300 degrees Fahrenheit. The next disturbance was a low pressure alarm at PRC 176, which controls the inlet pressure to the low pressure stage of the synthesis compressor 103J. The two alarm values gave warning to the operators to check the situation in the field. In the field, a high-intensity fire at the outlet flange of the methanator feed heater was observed. The flame was directed at the 16-inch pipeline methanator feed inlet. This line is responsible for directing the synthesis gas to the methanator via the control valve. Trip procedures of the entire unit were initiated, but after 3 minutes from the first alarm, the fire caused the pipe to fail from overheating. The moment the failure occurred, a massive pressure drop in the whole system was indicated at PRC 143. The entire front-end gas, approximately 280,000 normal cubic meters per hour at 27 bar and 335 degrees Celsius, was immediately ignited at rupture point. The burning cloud caused extensive damage to the instrument cables and accompanying instruments due to their close vicinity to the main supporting structure. Luckily, during the incident no operators were in the field, which prevented any injuries to personnel. Overheating of the instrument cables caused a total breakdown in communication between the instruments in the process field and the DCS system. Operators lost all ability to control the process. With the rapid intervention of the safety emergency shutdown valves and by closing the blocking manual hand valves to the main process streams, the process flow to the rupture was isolated and the fire extinguished. The duration of the incident from the appearance of the first alarm to the complete trip of the whole unit was 7 minutes. The consequential fire was extinguished within 12 minutes of the first alarm. In this case, the DCS operators did not receive a gas leak detection alarm. They only understood that they have a problem once they got main process parameters variation, and it was already too late to stop the gas leak. The gas cloud resulting from the leak was already ignited and impinged on the 16-inch pipeline methanator feed inlet, which led to the rupture. That means the gas leak was there longer than the operators realized. Now imagine if they could detect the leak from the early phase. If they could not only detect but visually see the leak from the moment it started. They could see the exact location, the size, the direction of the gas cloud. They could estimate the risk and would definitely have plenty of time to react and control the issue and stop the plant in safe conditions, preventing costs associated with extensive loss of production and with the repair work resulting from the damages. As mentioned before, existing gas detection systems are not 100% reliable and are influenced by the following factors: leak location, the hole size and orientation, gas pressure, piping congestion in the area, and the wind direction. Traditional emergency response training tells us that in case of an ammonia leak, the assembly point where you have to go will depend on the wind direction, and the announcement will tell you exactly which assembly point you have to go to. But is this empirical way of selecting the assembly point enough nowadays? For those caught in an ammonia cloud, the suffocating sensation and the panic that gets installed once you feel you cannot breathe is a forever living memory. As you move through the cloud trying to get out, you cannot stop thinking, how big is this cloud? Would I ever get out of this? There is the need for an additional layer of protection that would give the operators an edge over the invisible gas cloud. Situation assessment just means overview. We want to introduce an entirely new way of detecting hazardous gas clouds no matter where they are and what the gas is. Grandperspective provides, with the Scanfeld early warning solution, a remote monitoring tool that detects gas clouds optically from kilometers away. Grandperspective developed the new early warning solution, the Scanfeld. This is the recording of a release experiment that was conducted with a harmless release of ammonia water to simulate an ammonia gas leak. The Scanfeld measurement unit moves and picks up the signal of the gas. In the control room, the operators instantly see the gas cloud distribution. The Scanfeld measurement unit uses Fourier transform infrared spectroscopy for chemical identification and the assessment of the entire gas cloud. The optical measurement technology works at kilometers distance and identifies the chemical composition of the gas cloud for hundreds of different chemicals. You can build up a monitoring solution to cover entire chemical plants by combining an arbitrary number of Scanfeld measurement units with our software modules for chemical identification and cloud visualization, automatic incident classification in warning levels, and live gas cloud tracking and hazard zone mapping. Situation assessment is visualized in an intuitive gas cloud display with alarm logging and an interface to the DCS. On any device, including handhelds, the user can assess present situation as easy as all prior events. The Scanfeld early warning solution provides answers to the questions of where is how much of which hazardous gas. The Scanfeld early warning solution brings in a series of mitigation barriers that can prevent major consequences. Using remote sensing in combination with cross-link sensors, Scanfeld can detect the leak, identify the chemical, locate the leak source, and perform cloud tracking and perimeter monitoring, preventing major consequences like fire, inhalation by co-workers, uncoordinated emergency response, and exposure of the general public. Such a clear video representation of how keep it in the pipe works for your plant will help the operators to take a clear decision when to stop the plant. To see the leak is definitely much better than guessing leak location and cloud size based on field measurements. Plus, you never know how long that leak will stay at the same rate. Any change in hole size or wind direction can push the gas cloud closer to an ignition source. Scanfeld will help you locate the leak source and track the gas cloud more accurately, leading to more informed decisions regarding plant operation in critical times. Given the limited potential for passive and constructive protection improvement, insurance companies and auditors are stipulating higher standards for early warning systems. The Scanfeld early warning solution provides an answer. Huge areas that were not monitored before can now be under 24/7 surveillance, sometimes even with a single remote sensing unit. In this webinar, we have shown how gas leak detection at an early stage is vital for hazard prevention and rapid incident mitigation. By today's standards, operators have to make their decisions based on sparse information of gas sensors. This involves the danger to act with too little, too late. Remember that over 30% of all major gas leaks are undetected by gas sensors. Early warning by remote monitoring closes the gap and provides the necessary overview. We introduced the Scanfeld remote monitoring solution that monitors huge areas, identifies the chemical composition and tracks the movement of a gas cloud. It can locate the gas leak and informs the operators in the control room and in the field immediately with an intuitive visualization of the cloud. To learn more about our Scanfeld early warning solution, please visit our website at www.grandperspective.de or contact me directly at braun@grandperspective.de.